In this video, I'm going to be going through the misconceptions around working with exact trigonometric values. I'm not going to explain in this video where these values come from and which of these and methods to remember them. If you want to explore that further, if you're unclear on that, you need to go to Hegarty Maths Clips 845 to 849. However, I do just want to identify something here that may cause a bit of confusion, and that's to do with the values for sine and cos of 45 degrees and tan of 30 degrees, which you will have seen maybe in this form, but more likely in other forms. And I just want to identify that these two are the same thing. So when you were working with the angle, with the sin, cos and tan for 60 and 30, you likely use the equilateral triangle, which is split down the middle to make the 30-degree angle. And then you use Pythagoras' theorem to probably identify this side as root 3. And the same with the isosceles triangle, where you've got a 45-degree angle. And your side lengths with the non-hypotenuse sides were 1 each, and then you worked out the hypotenuse by doing 1 squared plus 1 squared square rooted and got root 2. Now that means that when you came up with the value for tan of 30, you will have got tan of 30 is the opposite over the adjacent, which is 1 over root 3, but the value presented here is root 3 over 3. And all that is where we tend, with fractions, we tend to not present them with surds in the denominator. Instead, we rationalise the denominator. And we do that by multiplying numerator and denominator by the same thing, in this case root 3, to eliminate the surd on the bottom of the fraction. And what you can see is we have 1 over root 3 is exactly the same as root 3 over root 3 over 3. And the same is true for cos of 45 degrees and sine of 45 degrees. You would here have got 1 over root 2 from this triangle as the value. But because the surd is on the denominator, we would multiply that by root 2 over root 2 and get root 2 over 2 as the rationalised form of that value. So just be aware that you can have those presented in 1 over root 2 or in root 2 over 2. And they are both exactly the same, just one is rationalised and one is not. So then, what type of questions could we ask? Now, it could be that you're given multiple choice questions, which are just asking you to straight up remember what one of the values is. And that is just a case of recalling. But we may have these questions embedded where we've got to manipulate them. In this case, this is a manipulating question. We might have to use Pythagoras' theorem areas of triangles. We might have to use them alongside other skills. But these are the two questions I'm going to look at in this video. So angle x is acute. So first of all, that tells us this angle has to be less than 90 degrees. Cos x is equal to sine 60 times tan 30. So what you're going to need to know is the values of sine 60 and tan 30, and we're going to multiply those together to work out the size of angle x. So notice here as well, we're going to be going back to what the angle is and not what the value of cos of the angle is. So that's a little thing to be aware of when we come to the answer. So we're working with the 60-30, and when I do these questions, I like to just draw that triangle out so that I'm sure I'm getting the right values. And I know that this is 1, this is 2, and this was root 3 for the 60, 30, 90 triangle. Okay, if I'm working with sine 60, so sine 60 is opposite over hypotenuse. So that would be root 3 over 2. And I'm timesing that by tan 30. Now, it's different angle now, so tan works with opposite and adjacent, and if we're working with a 30-degree angle, this is O and A. So just be careful if you are using the triangles as a way of remembering that you make sure when you're working with different angles within the same triangle, you do relabel those sides. So this would be opposite is 1 over adjacent, which is root 3. And remember that 1 over root 3 can be presented in the rationalised form, which would be root 3 over 3. So it depends what you want to work with here. Okay, I am actually going to use this form because I know I'm going to be multiplying them together. And so when I multiply root 3 by root 3, I get a rational value. So I'm going to actually change that to root 3 over 3. And then I'm going to times my numerators and my denominators, which gives me 3 over 6, not 2, 3 over 6, which is equal to a half. So we have the value now of cos x. cos x is equal to a half. Remember, x is the size of the angle, and I need to report that. So where is x? 1 over 2. Well, actually, we can see it's in this triangle as well. Cos relates to the adjacent and the hypotenuse, the adjacent over the hypotenuse. So what I want is for the adjacent to be 1 and the hypotenuse to be 2. So if I change this around, this is the adjacent, this will be the opposite, this is the hypotenuse. So this is the adjacent side to the angle of 60 degrees. So you can either just remember that cos of 60 is a half, or if you can't remember that, you can use your triangle to figure it out. But the answer here is that x equals 60 degrees. Okay, and in the second question here, we want to show that this is an integer, so we're thinking that the answer has to be a whole number. We want to show that this has a whole number answer. So again, we've got 30, 60 and 30, so we're working again with this triangle, but we may need to move those sides around depending on which angle we're working with. So here's my 30 degree, here's my 60, and here's the right angle. So cos of 30, so I'm going to do this in a different colour, cos of 30, so the 30 degree angle, cos is adjacent and hypotenuse. So that's root 3 over 2 times by tan of 60. Now we're working with the 60 degree angle now, so my adjacent and hypotenuse will, my adjacent and my opposite will have switched. So 60 degrees, this becomes the opposite, this becomes the adjacent. So tan of 60 is root 3 over 1, just root 3. And then we're going to add on sine of 30. So I'll use another colour again. So the sine for 30, I'll go back to blue. So for the 30 degree angle, we need sine, that's opposite over hypotenuse, which is a half. Again, you can have just remembered those values, but if not, you can use your triangle to find them out. So then we're going to simplify this now. Binmas says we're going to do multiplication first, so that gives us 3 over 2. Root 3 times root 3 is 3. 2 times 1 is 2, plus a half. 3 halves add 1 half is 4 halves, which is the same as 2, and we can see we've got an integer.